Hi guys, I just wanted to finish page 10 from the packet with you. Do me a favor, don't take out the packet just yet. I just want you to watch, and then when I'm done with the video, I want you to go to page 10 and finish it. So it's the problem where you're throwing a ball vertically up. I know we did 1 in class, we did 3, and I just was taking this information, the 6 seconds where the ball hit the ground, and drawing a quick sketch. So again, just pay attention, and I don't want you to copy at the moment. So time, instead of x's and y's, they have t's and h's. So time goes here, that's seconds, and the height of the ball goes up there. And then remember, I had to extend it a little so I can sort of plot the -1, which is the other root. Right, when you put the entire function equal to 0, we just got the 2 x-intercepts. Obviously, we're going to say 6 is the answer because in real life you can't have time to be negative. But if it's just a simple graph, we can plot the -1. And then here we plotted the 6. So this is -1, this is 6. And then we're going to eyeball when time is 0. Let's eyeball that this is 96. And then this is what I was doing in class. We quickly found the midpoint just so I can see what the vertex is. Right now, I'm just going to eyeball it, and we'll find it again because I know the bell is going to ring. I'll find it again in a second. So let's imagine, even though this does not look really nice, can we just, it's just a sketch, so I'm hoping you can work with this. And now, my ball falls on the ground at 6 seconds, and the answer is 6 seconds. Let's go on to 4. At what time will the object reach its maximum height? So they want time, they want t, and if it says when will it reach its maximum height, you know this is where the maximum height occurs. It occurs at the vertex. And so because it said what time, they want the x value. And this is what I was trying to do while right before the bell rang. I was trying to find the midpoint between these 2 x-intercepts so I can find the x value of the vertex. So let's make sure you understand why number 4 wants the x value. So let me write that down. If it says what time will it reach the maximum height, we need x value of the vertex, because the vertex is the tallest spot, and we want the x value. So here's what I was doing in class. This entire thing, this entire segment is 7 units long. Half of 7 will give me 3.5 and 3.5. And so from 6, let's go left 3.5. And if I do 6 minus 3.5, I get 2.5. So the x value, it's 2.5 seconds, is when the ball will reach its maximum height. Okay, I'm going to go on to 5. What is the maximum height? So we know when it reaches the maximum height at 2.5 seconds. What is the maximum height? So I'm hoping that you know what they're looking for. They now need the y value of the vertex. We just found the x value to be 2.5. That's the time it reaches the maximum height. What is the maximum height? They want me to take this 2.5 and plug it in to the original problem and get the y value. So again, we know 2.5 is the x value. What is the y value? That's what we need. So I want you, we're going to go find h of 2.5. This is when you do it, go grab your calculator. Let's go back to the original. Careful with that negative. Plug in 2.5 everywhere you see t. 2.5. Grab your calculator and go work this out. And then that's going to be feet. So grab the calculator and work it. Finish this part. All right, last one, 6. Identify the domain and the range of this situation. So I think the graph is really helpful. So the domain and the range, and we're not looking at this negative part because time can't be negative. So domain are the x values. My smallest x value is 0, and my largest x value is 6. Because after 6 seconds, like this whole story ends because the ball hits the ground at 6 seconds. So my domain is from 0 to 6. Okay, range. What is the smallest height? So raise up and down. What is the smallest height of my ball? It's 0. What's the largest height? It's whatever the y value is of the vertex. So whatever you get for number 5, this number, that is going to end up being the number on the right for the range. So one more time, range is up and down. The smallest y value is 0 because height cannot be negative. The largest y value is where the vertex occurs, and it's the answer for number 5. Okay, now stop the video and go back and do page 10 on your own.